We'll now discuss California Mechanical Code Chapters 6 and 7, which deal with duct systems and combustion air. Chapter 6, Duct Systems, begins with describing the requirements for materials to be used in actual HVAC systems. And generally speaking, ducts, plenums, any fittings, etc., required to be constructed of metal must comply with SMACNA HVAC duct construction standards, metal and flexible, or Underwriters Laboratory 181. Additionally, in addition to ducts, concealed spaces within buildings or independent construction within buildings are also permitted to be used as ducts or plenums for HVAC systems. Vibration isolation connectors are required to be installed between mechanical equipment and metal ducts, and are also required to be made of an approved material and not exceed 10 inches in length. All materials that are exposed within ducts or plenums are required to be non-combustible or have a flame spread index of 25 maximum and a smoke development index of 50 maximum. Now there is of course an exception to this, and that is for plenum installations. If there are products that are listed for plenum installation, they're also acceptable. For instance, electrical wiring, fire sprinkler piping, any pneumatic tubing, loudspeakers, recessed lighting, and a whole variety of discrete mechanical, electrical, and plumbing components. So it's very important that the project inspector reviews any materials that are installed within plenums to make sure that they are plenum rated. All ductwork is required to be supported at every change in direction and at regular intervals as specified in the SMACNA manual. They are required to be supported per the California Building Code requirements, obviously for structural concerns that exist here in California. For rectangular ducts, the supports have got to be installed at two opposite sides of the ductwork itself, and these are typically either riveted, screwed, or bolted. Now for horizontal round ducts, single hangers are acceptable, and the single hanger is generally going to consist of a tight-fitting circular band, which is required to be 1 inch minimum wide and have the same gauge thickness as the duct it's supporting. And additionally, 18 gauge wire is permitted for round ductwork that is less than 10 inches in diameter. All flexible ducting is required to be installed, of course, in accordance with the manufacturer's installation instructions and also the SMACNA HVAC duct construction standards for metal and flexible ducting. There's some new amendments, new information to the California Mechanical Code, but not necessarily new to the installation requirements for ductwork, and they're included as follows. For flexible ducting, the contractor is required to use the minimum required length. Horizontal runs of flexible ducting must be supported at 4-foot maximum intervals. Vertical risers of flexible ductwork are required to be supported at 6-foot maximum intervals. And the sag that is permitted in flexible ductwork between support hangers is 1/2 inch maximum per foot. Additionally, supports for flexible ductwork are required to be rigid, 1.5 inch minimum wide at the point of contact. It's also very important to make sure that flexible ductwork does not become restrictive So duct bends are required to be 1 duct diameter minimum bend radius. Screws are not permitted to penetrate the inner liner of non-metallic flexible duct. Fittings that attach the flex duct are required to be beaded with a 2-inch minimum collar length. The inner liner has to be installed with a 1-inch minimum overlap on the collar and certainly past the bead. The outer vapor barrier is required to be secured with 2 wraps of approved tape. Flexible duct is never permitted to penetrate any fire resistance rated assembly or construction. The temperature that's conveyed inside of flexible ductwork is restricted to a 250 degrees Fahrenheit maximum temperature. And flexible ductwork is required to be sealed in accordance with section 603.10, which contains a variety of different methods and additional details for sealing the duct. This slide shows a couple of images that are important. The image on the left is obviously a problem from the perspective that it appears, looking at the fire caulking or the caulking itself at the penetration, that this particular wall construction is fire resistive, and therefore flexible ducting is never permitted to penetrate any type of fire resistant duct. And additionally, as we all know, most all fire penetrations or fire construction penetrations have got to be a UL listed assembly. So if there's any questions relating to what is permitted to penetrate fire resistive construction, it would be certainly acceptable or expected to be able to see a UL listed assembly identified on the plans showing all of the details for a penetration of such construction. The image on the right doesn't necessarily show a deficiency. I know it's hard to see what's going on with this large metal rectangular ducting, but the information to take from this installation is that in situations where it may appear that the duct is quite a ways away from the support in this area being the upper ceiling height, it is certainly worth looking in great detail for any type of seismic bracing which may be required due to the extreme length of the hangers and possibly the weight of the ductwork. Again, all of this information is going to be included in the plans, and if it's not, it is certainly appropriate to start asking some questions, either of the district structural engineer or the design professionals on the job itself. This slide shows a couple of images of inappropriately installed flex duct at a register. Obviously, the image on the left and the right are showing situations where the flexible ductwork is certainly pinched off, and the minimum required bend radius has not been maintained. And I would also argue that the contractor has not used due diligence in ensuring that the shortest piece of flexible ductwork that is required is being used. There's certainly way too much flexible duct being used in these two applications. The picture on this slide shows a situation where the actual sheetrock and the wall finishes are going to impede the ability for this damper to even be adjusted at all. As you can see on the left-hand side of the picture, or of the round ductwork that's penetrating the wall, the actual nut on the other side, excuse me, is completely enveloped in sheetrock mud, and there's just no way that this damper is going to be able to be balanced or moved to balance this system. New to the 2019 version of the California Mechanical Code is this section 603.10.1, which addresses duct leakage testing that is required. Ductwork is now required to be leak tested in accordance with the SMACNA HVAC Air Duct Leakage Test Manual. And generally speaking, it's a progressive leak test based on results. So at the onset, sections to be tested obviously are going to be selected by the building owner or their designee, and 10% minimum of the total installed ductwork must be leak tested. In the event that 10% fails, then 40% of the total installed ductwork is required to be leak tested. In the event that 40% fails, then 100% of the total installed ductwork must be tested. And obviously the purpose for this testing is to determine where the leaks are and to also fix the leaks. Now there is a permitted leakage amount that's identified in a formula that's located in section 603.10.1, and the contractor is going to refer to that particular formula in order to identify if any leakage that is detected is within the acceptable parameters that are required per the CMC. There are situations where ductwork is required to be insulated as well. Any ductwork that is conveying air that is greater than 140 degrees Fahrenheit is required to be insulated to maintain 140 degrees Fahrenheit maximum surface temperature on the ductwork itself. In situations where the insulation is installed on the exterior insulation must identify the manufacturer, the R value of the insulation, the flame spread index, and also the smoke development index of the insulation. In situations where the ductwork is insulated on the inside of the duct, special precautions have got to be taken to make sure that the material that's used is going to be resistant to mold, humidity, and also the erosive effects of the air that's being conveyed within the ductwork. Also, the insulation is required to comply with UL 181 requirements for material construction. Additionally, where the air velocity being conveyed inside the ductwork exceeds 2000 CFM, the insulation is required to be fastened with adhesive and mechanical fasteners, and all of the exposed edges are required to be treated to make sure that the insulation will stay adhered to the inside of the ductwork and will not come loose. Section 605 addresses requirements for smoke dampers, fire dampers, and also ceiling dampers. These components, of course, need to be installed in compliance with the manufacturer's installation instructions, but it's also important to review to make sure that the standard is referenced in also Chapter 17 of the California Mechanical Code in the tables, and it's also important that these are listed by an approved agency. Smoke dampers obviously need to comply with their listing, and their listing is identified as UL 555S. Fire dampers are required to comply with UL 555, and ceiling dampers are required to comply with the listing UL 555C. It's also important to look for the breakaway requirements for each of these devices and the size of the openings, whether or not it's one or two-sided angle frame requirements that have got to be adhered to. And it's also, of course, very important to verify that the damper blades are installed within the plane of the rated wall. A lot of these things, or most of these things and more, have or will be identified and discussed in the fire life safety portion of the Product Inspector Overview class. Additionally, access panels are required to be provided for any smoke or fire damper to allow for inspection and maintenance of the components inside. A permanently identified sign is required with 1/2 minimum high letters stating the damper type, whether it's a smoke damper, a fire damper, or a smoke/fire damper. This image shows an example of a standard fire damper installed in a wall, obviously a fire resistive rated constructed wall. At times, the air supply being conveyed through ductwork is required to be automatically shut off, and this will happen whenever the air that's moving within the system is exceeding 2,000 cubic feet per minute. They must be equipped with an automatic shutoff. The automatic shutoff is accomplished when the system detects smoke via a smoke detector, which is installed in the main supply air ductwork served by the equipment. The smoke detectors that are installed within ductwork are required to comply with UL 268A. They're required to be labeled, approved, and listed by the California State Fire Marshal. They're required to be installed in compliance, obviously, again, with the manufacturer's installation instructions, NFPA 72, the California Building Code, and the California Fire Code. And these detectors are required to also be supervised by the building's fire alarm system. Chapter 7 of the California Mechanical Code is basically a verbatim duplication of the California Plumbing Code's Chapter 5, which deals with water heaters, specifically Section 506. And we're not going to duplicate any of that information here in this mechanical presentation. In general, however, air that's used for combustion, ventilation, and dilution of flue gases is a very important topic, and the systems will be designed and documented as required in the plans. So the best advice to give is to, or simplest advice to give, obviously, is to inspect the installation of any combustion air systems based on the approved plans and specifications. There are a couple of additional topics worth discussing. One of them is the fact that combustion air ducts or plenums are not permitted to penetrate any fire-resistive construction, and manual dampers in combustion air openings are absolutely prohibited for obvious reasons. Additionally, no device or attachment is permitted to be installed on any appliance which may impair the combustion process.